Okay, the next standard that we're going to work on involves things that cause a graph to shift up or down or left or right or flip or open or close. Today we're only going to focus on horizontal and vertical shifts. So this is part of standard FBF3, but it's the only part we're going to work on for today. So FBF3 says the standard is identifying the effect of replacing f of x by f of x plus k or f of x plus k on a graph. So let's look at both of those using a graph that we know, and that is f of x equals absolute value of x. Okay, so we all know from our last unit that that looks like this. All right, so that is the graph of f of x is the absolute value of x. Okay, so now let's throw something on to the end of that. Let's, instead of graphing absolute value of x, let's graph the absolute value of x plus 2, for example. Okay, well, if we think about this for a second, what that is going to do is whatever my x value was, it's just going to add 2 to it. So let's look at a couple points and see what it does to the graph. So if I plug 0 into here, the absolute value of 0 is still 0, but then I'm going to add 2 to the end. Okay, at 1, absolute value of 1 is 1, plus 2 is 3. So that's right there. Okay, negative 1, the absolute value of that is 1, plus 2 more is right there. Okay, this one. Let me back up and fix that point. Okay, and for every point along here, you'll notice that this point is just going to be 2 higher. Okay, so that first graph was y equals absolute value of x. This one is y equals the absolute value of x plus 2. And so you'll notice what happened there is that the graph just shifted up 2. Well, let's do the same thing but shift it down 3. All right, so now instead of f of x, let's look at f of x minus 3. Well, again, at 0, right, I'm going to be absolute value of that is 0, and then minus 3 is 1, 2, 3 down there. At 1, absolute value of that is 1, minus 3 would be at negative 2. At negative 1, I will also be at negative 2. And so there is the graph of f of y equals absolute value of x minus 3. Okay, so from that, what we can see is that just adding or subtracting some number onto the end of the function just shifts the graph up or down that amount. Okay, so the formal way that we're going to write this is that to shift up f of x plus k will just shift up k units. Okay, f of x minus k, that will shift down k units. All right, so that's sort of the first part of that we're looking at. So f of x, if it's my original function, but just plus or minus something on the end, that's just going to shift it up or down. Okay, likewise, we can look at, well, actually, I'm going to back up and go to looking at the graph to tell what the equation is. Let me do left and right shifts first. So let's look at the other option that we would have here would be instead of having absolute value of x, we're going to do absolute value of x plus 2. Okay, so now what we're going to do is do a plus or minus, but we're going to do it inside the absolute value. And let's graph that over here just so I save some room. All right, so now remember that my original graph would have been f of x, and it would look like this. Or sorry, f of x is the absolute value of x, and it would look like that. Okay, so now let's graph this instead. So plugging in a 0 for x, right, we're going to get 0 plus 2 would be 2, and the absolute value of that is 2. At 1 plus 2 would give me 3, the absolute value of that is 3. If I plug in a 2, 2 plus 2 is 4, absolute value of that is 4. Now it sort of looks like we're just shifting up 2 units, but watch what happens if I go this way. So if I plug in a -1, -1 plus 2 would be 1, and the absolute value of that would be 1. If I plug in a -2, -2 plus 2 would be 0, and the absolute value of that would be 0. Plugging in a -3, -3 plus 2 would be -1, and the absolute value of that would be 1. Plugging in a -4, -4 plus 2 would be -2, absolute value of that is 2, so on and so forth. So you can see this didn't do an up or down shift, this did a shift to the left, where every point is now 2 units over to the left from where it was. This point got shifted over 2 to the left. All right, well, let's look the other way. Let's look at absolute value of x, say -3. Okay, so our first guess here might be to say, oh, well, when it's plus 2, it shifts 2 to the left, so maybe 3 shifts 3 to the right. Let's see what happens. All right, so if I plug in 0 here, I get absolute value of 3, which is 3. If I plug in a 1, I get -2, absolute value of that is 2. If I plug in a 2, I get absolute value of -1. If I plug in a 3 minus 3, I get 0, absolute value of that is 0. At 4, I'm going to get absolute value of 1. At 5, I'm going to get absolute value of 2. And so as you can see, in fact, putting a -3 in there did shift it over 3 to the right. So what that tells us is that adding a plus or minus sort of inside the function, where here like the function was absolute value, right? So putting a plus or minus number inside that absolute value shifts it left or right. So what we're going to say about that is that f of x plus k is a shift left k units, and f of x minus k is a shift right k units. All right, so now knowing that lets me be able to do that with any of those graphs that I've done. So just for example, knowing like that y equals x squared, so a quadratic, right? And we would know that the general y equals x squared looks something like this. We can do either of those things to this, and it'll tell us whether to shift it left, right, or up and down. So for example, y equals x squared minus 2, well, that would just shift this whole graph down 2. So if I'm shifting down 2 units, and we'll say that's at -2, right? Then we just get a graph like this. What if I wanted to shift it left or right? Well, then I would have something like y equals x plus 2 squared. That would shift it left 2 units. So that would be a graph like this over here. Okay, notice it's this plus or minus 2 or plus or minus 3, this addition and subtraction goes inside the function. So here the function is something squared. So now instead of something squared, I have something plus 2 squared or something minus 3 squared. Now what this lets us do also is that if we look at a graph we can tell what the equation of it is without even having to do any math really, but we can just shift the function. So for example, let's say that I had something that looks like a parabola, but the vertex is right there, right? And it opens something like this. Well, this sort of looks like where I have f of x equals x squared. But things are obviously shifted here. We have a shift to the right, and we have a shift down. Well, how do I shift it to the right 3 units? To shift it to the right 3 units, I would go x minus 3 inside my function. And then to shift it down, I would go minus 1 at the end. All right, so this is the graph of this. And I can do that just by looking at the graph of it. Likewise, if I have a absolute value, right, and say, for example, it starts out here, it goes over like this, well, what does that look like? It looks like f of x or y equals absolute value of x. But I know that this point is shifted 3 to the left and up 1. All right, well, how do I shift it 3 to the left? I put x plus 3, whoops, absolute value, not parenthesis, x plus 3 in the parenthesis, or in the absolute value, and then to shift it up 1, I put a plus 1 at the end. So this would be the equation of that. Okay. The only practice that I want you to do here is you're going to graph some absolute value equations by shifting them, and you're going to write the equations by looking at the graph. And this is actually can be very quick, because if you know that, say, for example, y equals absolute value of x plus 2 minus 5, you now should be able to look at that and say, okay, well, I know an absolute value graph looks like a V, and I know that this is telling me to shift it 2 to the left, and this is telling me to shift it 5 down. So if I take the starting point of a normal absolute value graph and shift it 2 to the left and down 5, okay, now I'm just going to start it there instead of at 0, 0. And then it just goes up like that, and up like that. Okay, so I can graph that without having to like plug in points and get, do a t-bar to get my coordinates and then graphing a bunch of dots. I can graph these very quickly once I sort of get the gist of this. Okay, I think that's good enough for you to be able to do the assignment. If it's not, we'll go over it on Thursday. Don't freak out about it. But I think you should be able to do this one pretty quickly. And I will see you Thursday.